Hello and welcome. My name is Bob Tickleman and I'm a Microsoft technical trainer. I'm here to inform you on the series of what you want to know when you want to know it. Today we're going to be looking at designing Microsoft Azure infrastructure solutions as part of the AZ-305 course. This module is going to be focusing specifically on application architecture in relationship to more of the modern application designs around microservices. We've covered them in some of the other modules, or hopefully you're familiar with them, but really these plays come into account when you get around from the monolithic applications and really can leverage the microservices. We're going to be taking a look at several forms of types of data and information. The term is called decoupling of your application. And so we're going to look at a variety of different queues that we have available for us. And they break up into several different types of queues. We have hubs for events and event grids, and we have service bus and message queues where you have messaging. So we're going to take a look at these different types of solutions that we have, whether they be entry level or enterprise grade for event-based handling or message-based handling. We'll also take a look at some of the optimization capabilities that we have for application lifecycle management as you get more into that DevOps environment, managing features like feature toggles and feature flags, configuration files, and ways to automate this. So we're also going to introduce some of the newer methods that you deal with IoT. In the past, we used to have event grids and event hubs to handle that kind of information. Sorry, I said it's event hubs, but now we have IoT Hub, which has a slight different capability because it provides bi-directional communication through the queue itself. So let's delve into these design solutions that a microserviced, event-driven based process could really leverage. Let's get into the lesson. When you take a look at queuing, you want to be able to, in modern applications, to be able to decouple the services that you're building in a microserviced environment. Let's take a look at what this means, and we'll take a look at the two different types of events that we have available. Things referred to as messages, which are data sets deposited into this thing called a queue. And we'll take a look at a record of some kind of activity, which is an event-based queue. One is a lightweight-based set of data. One contains raw data about things like a purchase order that you're taking a look at. So we're going to go take a look at this scenario, and we'll come back and then compare these topics to the chart itself. If I have a modern-based application that is running as a microservice, I've got a front-end based application across the top, represented by my red triangle, green triangle, and blue triangle. And it's going to interact possibly with a middle business tier, which are represented by the circles, and a back-end data tier represented by these squares. I've got an application that might have a front-end web application that all of a sudden, for some reason, has gone crazy. Maybe I appeared on some celebrity's favorite list, and they've come to my website. And so I have this massive scaling of potentially millions of users coming to my website. I don't want to have, in a monolithic application or a direct coupling, I don't want to have that directly impact other portions of my application until something triggers that kind of activity. And this is where we're going to make that distinction between a message-based versus an event-based type of queue. And the queue is going to provide the decoupling of these services. Of the millions of users that come to my web app, maybe only 100,000 of those people actually put something into a shopping cart. I don't need to have a direct coupling of the two services, but now what I have is through some kind of activity, whether it be an event like someone putting something in a shopping cart, I've triggered a scaling of a separate part of my application. So based on some activity or event, I can now trigger an application. I'm going to move further ahead for just discussion purposes that eventually some of those people, maybe 10,000 of them, have actually purchased the app products that they put into their shopping cart. I've now verified, you saw that check mark indicate that they have been notified that we've fulfilled their order. And now I've got a completed order. I mail that order message to them so they have a record of it. But now I need to move that message along further in my processes to actually have it run against the database. You're seeing here in the middle circle, I've got another type of queue that the orders are going to be filled into in an orderly process. Now, opposed to just a record of some kind of event, the actual message of the sales order is going to be deposited into the queue. It exists in a thing called a first in, first out order processing, because it would be unfair if someone jumped the queue and got their order in ahead of mine because maybe there was smaller numbers on their order item, because I need to be able to run that against the database. So there's an example of two different types of queues that we have. One is going to be based around some kind of activity, an event, and one is going to have a message and have some kind of processing requirement that goes against it. So taking a look at the types of message and event-based scenarios, we've seen that we have queues, and we'll take a look at the different products that we have available to do this. But the two types of queuing that we have, event queues and message queues, and within each one of those, there's two kinds, one that provides enterprise-grade services and the one that provides more of an entry-level, non-mission critical type of environment, event queues and message queues. Today, I'm going to be talking to you about Azure architecture and specifically designing message-based solutions. When we take a look at message-based solutions, one of the major concepts that we want to get into is the concept of decoupling. As we get into modern application development, you no longer have monolithic applications where there's one application regardless of how many people are using that application to perform all of its functions. In a modern application, you have microservices, and you do not want to have a direct coupling of two different services because as scaling might happen and workloads increase, you do not want a corresponding response by another potential workload that may or may not need to be triggered. And so this whole concept of queues provides this major concept of decoupling. So what you're seeing on the slide on the left-hand side is a generator of some kind of activity. And for maybe it's a website that you have and you've appeared on some celebrity's favorite list, and all of a sudden your website goes crazy. People may be putting things in shopping carts, but there's no need to trigger the purchasing portion of your application because nothing is yet to be purchased. So you can have this massive scaling on one part of the application, and only when a message has been generated, so some type of data. So in this case, it's going to be an example of an order actually being fulfilled. When that purchase button has been pressed, it then takes the message, the order itself with the order number, the products that were ordered, the quantity, and it deposits that data into some queue. That message lives in the queue and then is a trigger to the event that says, I need to now process this message and go through what's called order fulfillment. I need to check the database to make sure that we have those objects. We decrement those numbers from the database and we complete that order. But now what I can now have is my purchase application has disappeared and I can now scale up independently. The other thing is it allows you to have SLAs or service level agreements, because maybe your order fulfillment application does not have to have a direct correlation, a one-to-one relationship with the topic generator. We maybe have a function that can now perform, say, 1,000 order fulfillments per minute. If there's only 5 items that are in the queue, I don't need 5 of them because it's going to process all of the messages in the queue within the SLA timeframe that we've specified. So message-based queuing provides this decoupling of my application so that I get proper and economic scaling of my application. It also provides for the resiliency of the application because let's say that the order processing portion of my application for some reason doesn't kick off. I don't want to lose the order. The information has been submitted to the queue and can live in there for a TTL or time to live until the message has been picked up and processed. You'll see that these are typically worked with either HTTP or HTTPS types of communication and provides for secure message deposit and retrieval of that information within the queue. Within the messaging queue systems that we have available for us, we have two types of queues themselves. There's the service bus queue that's available for us, and the idea of this thing called a topic. So you have the sender of the message. You're seeing that on the left-hand side of the slide, where the sender or the generator of that message creates the message itself. It has deposited that message into the queue. And then what we have is a receiver or a subscriber of that message to be able to come into the queue and pull that message out. Where this is different from the other type of messaging queue, which is part of an Azure storage account, we have Azure queues. They provide for message deposit, but they have a very small capacity. The size of the message that can be deposited, as well as it doesn't provide some of the SLA arrangements that Service Bus provides. We often refer to Azure queues as an entry-level or non-enterprise grade service that's available to you, where Service Bus provides a whole set of built-in services like guaranteed FIFO, first in, first out. It guarantees order processing that happens within the queue. So there's some differences between the two types of queues that we have available for us. So taking a look at those queue solutions that we have, I mentioned the queue storage account. You're seeing that at the top of the slide. It provides for simple queue organizations. It has massive capacity to store the amount of messages of up to 80 gigs in size. That's the size of the queue. But the actual messages themselves are quite small. You're seeing that comparison against the Service Bus queue that I mentioned, where the Service Bus guarantees that first in, first out type of processing that you might need in an enterprise grade application. It provides the at least one message processing, the ability to, if a message needs to be bifurcated, the term is to split it across multiple messages because maybe the type of information exceeds the message limit for the queue. It needs to be able to go through the queue and find its corresponding parts to be able to get all of the information together for that. So you're seeing that there's some slightly differences between the two types of message queues, part of a storage account, and then the Service Bus being the enterprise grade, as well as the entry-level storage account. Today, I'm going to be looking at Azure architecture and specifically designing an event-based solution. When we take a look at event-based processing, this is going to be a record of some kind of activity of an event taking place. It is still a type of queue, but the type of information that exists in the queue is around the record of an activity. We are still going to have what's called a pub sub or publisher subscriber model with things called topics. And so what you're seeing here is we've got two levels of event-based processing. There's one called Event Grid as a default service inside of Azure. It has, for all activities inside of Azure, the ability to keep records of all the activities that are performed. For example, on an Azure storage account, every activity, the creation of the storage account, the addition of objects to the storage account, the moving of objects in the storage account, the deletion of the objects in the storage account, all generate a topic of that activity and the information that are responding to it, the date, the time, what was the activity. So all of that information would then be deposited into the queue, and you're seeing that on the slide down the left-hand portion of the graphic. Every single Azure service has the ability as a publisher of these topics. So we have these event sources. These are our topics. And then the grid itself maintains this record of these queues. And there's a TTL for that topic to exist within that grid. We then have subscribers that would subscribe to the event grid to listen for the topics that they have subscribed to. So you can see here that you have what are called event handlers, and we have a wide variety of Microsoft services inside of Azure, as well as they can be external as long as they provide the ability to query the event grid itself. And so in this pub sub, we can now have triggered-based activities through a thing called event grid. You don't have to set this up. It's there by default, and you're going to be able to come in and query that information on a pay-per-use operation or a pay-per-operation type of payment system that you want to work with. As a general rule, all of these queues that we've taken a look at flow from one direction. We have event publishers publishing topics into whatever the queue is, and you have subscribers pulling those messages out. And this was the case until just recently. And what we've introduced into Azure is a new capability called IoT Hub. Very similar to the other types of queues that we have, based around the volume of IoT devices. We want a hub to be able to provide for that queuing capability of all of these devices, taking their messages or their event records and putting them into some type of queue, and then subscribers pulling that information, much like we saw before. But what IoT Hub does slightly different than all of them, it provides for a bi-directional communication. So through the hub, we can actually communicate back to the IoT devices. And this is going to be very useful in the case of being able to maybe provide updates, whether it be software-defined updates or configuration updates, back to those IoT devices. We can communicate through the hub itself. But IoT Hub is a very similar type of queue as the other queues that we've had, to be able to take events and or message queues and customize them specifically for IoT devices and be able to provide for this bi-directional communication. Let's take a look at event hubs. In a more sophisticated model, we have a thing called event hubs. This is an enterprise grade type of queue that you're working with for types of events themselves. As opposed to a default event grid, event hubs have to be configured. You would go in and create an account for your event hub. You would create an event hub itself, and then you would create the namespace for the hub to work with. Within the event hub, you'll see that you have the capability to create partitions. You can have at least one, and you can have up to 32 partitions to move the data across. Not at this level of the class, but these partitions are there to provide scale and capacity for you. By default, all the messages coming into the Event Hub get evenly spread across the partitions for processing, again, to provide some load balancing. But you can configure the partitions so that individual types of messages would go to specific partitions within the queue. In the event of when we used to have IoT coming into Event Hub, maybe you had temperature coming to one partition. Maybe you had air pressure coming to another one. Maybe you had humidity coming to a different partition, or did all of those three types of event activities appear across all of the partitions you're working with. What you use in here is this pull model allowing multiple readers. So you've got your event producers putting topics into the Event Hub, and then you get your event receivers subscribing to the hub itself. And what you can now have is the ability to have multiple subscribers subscribe for those events and then be able to trigger on them. And here we can see we have different receiver groups. We've got an orange group at the top and a blue group at the bottom, and they can query across the multiple partitions to be able to act upon the activities that exist within the Event Hub itself. So we're going to go in and take a look at a demonstration of setting up an event grid and an Event Hub. We'll see that we can query for specific activities within the event grid based around a storage account having something added to it. And then we'll see a similar activity in the Event Hub itself. In another lesson, we looked at the other types of queues being message. This slide is showing a comparison across the two major types of queues where we have event grids and event hubs for the tracking of event activities. And we have service-based, message-based queues that you're working with Azure storage accounts and service bus. You can see that two are based on messages, two are based on events. Whether it's based on big data or high volume service bus, those are your enterprise grade services that you're working with. The other ones, much less expensive, but they may not offer the full set of services that are needed for your application. So as an architect, make sure that you query the requirements to be able to select the right type of queue to deploy for your solution. Today, I'm going to be talking about Azure architecture and specifically designing an application optimization solution. When you build an application, specifically a microservice application, we want to be able to optimize our reads and writes. And this is also another form of decoupling your applications in this environment. One of the tools that we use is an industry standard product called Redis Cache. And it provides for a caching, which is just a technical definition for high-speed buffer between an area of generation of information and reading of that information. We have memory caching. You've probably heard that term before, but Redis Cache has been a tool that's been around to provide this capability. So let me give you a scenario of what this is going to do for us, and then we'll come back and take a look at what Redis Cache does. When you take a look at an application like a web application, you might have some form of a list of products that you sell. That list of products wants to be displayed on your front-end web page that you're showing your customers. I'm going to say that a lot of that information is going to come possibly from some SQL database, maybe in your data backend. And so for every web page that gets created, there is some read permission that makes a request for the list of products, and your SQL database would have to provide that list of products for that front-end web page. Well, imagine if you had millions of users coming to your website. If you had millions of users coming to your website with needs for millions of responses, what do you think that that would do to the performance of your SQL database? Probably wouldn't perform very well. What we want to be able to do is do this decoupling because it's a static list of the products that I care about. I don't need to have a real-time set of data, SQL data to be able to provide this information. So what we're going to do in this solution, we're going to provide some level of a caching system to be able to perform the read and populate the cache from the SQL database. So it's still an authoritative source of truth that's available to us, but it's now populated into the cache. And now what I can do is I can program my web application to now read from a static list of lightly formatted data. You remember from the data structures we took a look at, it's not highly structured, it's lightly formed, and it has much better performance to be able to do this. Now, in fact, we have 3 types of data that we can use as this caching system. We have Azure tables. We have Redis Cache, which is what we're talking about. And we have Cosmos DB. All capable of providing this function as a caching system to be able to provide high-speed buffer access to that information. Redis Cache performs in the 160,000 operations per second, so very, very high performance capability. It has the capability to scale and have replicas, where Azure Tables, as part of a storage account, you're only going to get that one copy, and it's capped out at about 20,000 operations. And going all the way up to Cosmos DB, you get global scale and replication capabilities, and you get into the hundreds of millions of transactions per second. So at completely different scales of operation, as well as cost. But I have the ability now to read the information, cache it, and then make it available to some operation that will come in and read it. Now, caches are typically programmed in one of 2 environments, a read-optimized cache or a write-optimized cache. In this case, this is a read-optimized cache. It's reading the information once, it's populating the cache and making it available to have other people read it from your cache. Now, I could also have another caching system where I write information to, instead of having to write it directly to the database, it then caches that information and stores it so that it can have a latency to the writing of that information. Now, in a high transaction database where that write is critical, you might not want to use it there, but where you can use what are called lazy writes, it's going to be more appropriate for us to work with. So Redis Cache is a service that is a platform as a service with inside of Azure. You don't have to install the Redis Cache software on a server. You can deploy Redis Cache at a variety of different service levels, provide high availability and fast responses to your requirements you're working with to provide that decoupling of the information through the cache system. This is part of an app gateway service that you have available to you to take a set of first-party and third-party APIs that you can bring into your company or that you can build using yourself. You could then store them in a secure environment using the API management solution. And then you could then take those APIs and put a full set of controls around them. So we take a look at creating what are called products, where you take an API. So for example, maybe I have a file write API, and that file command has the ability to write objects, copy objects, delete them. Those are a set of operators that apply on the API. What we can now do is take that first-party or third-party API, take it, and then publish it to a set of subscribers that may want to use for internal development or maybe external development, that API to communicate through it. I could then put a set of controls around there that then publish it to a gateway service that then people can consume my APIs. So what we can now do is provide a standard set of APIs and put specifications around them to our developers through this API gateway. And we have a whole set of services that work with this. Today, I'm going to be talking about Azure architecture and specifically designing an application lifecycle. When we take a look at lifecycle management, there's a term called infrastructure as code. As you go from an on-premises environment where you were required to build physically or virtually a set of services, in Azure, everything that you built is represented as what's called a JSON document. There is some type of code that is a representation of the infrastructure that you've built inside of Azure. And so being able to take that automation and that infrastructure provisioning, you can now use it to deploy your infrastructure and be able to maintain infrastructure management. Now, this goes hand in hand with other topics that we've talked about using Azure policies. So now as you run these templates and these scripts to build infrastructure, you have a set of policies that will make sure that everything that gets deployed is done so in a compliant manner. So infrastructure as code is a way to generate environments either as individual objects or a full suite of them at a specific time. We'll do in a demonstration in a bit that you'll see that I could take that infrastructure as code that maybe something's already been deployed. I can actually download that script that is a representation of that infrastructure and use that as a template to redeploy the information. It's also a way for us to then be able to measure, similar to what we did with policies, any type of drift that might take place. And so as soon as you deploy, typically IaaS or VMs in infrastructure, as soon as they're deployed, they start to drift from that initial configuration. And so what is an acceptable drift out of that initial configuration? We can have to measure it against the baseline. And this whole concept of infrastructure as code, represented by some type of set of program that you could then use to measure it against. So what we now have is a way to provision these resources. I mentioned that you'll see on the graphic on the slide coming from the right. What you have is a JSON document. I mentioned previously that every single information that lives inside of Azure is represented through some JSON document. When you take a look at the Azure infrastructure itself, everything is going to be represented by that JSON document. What I want to do is show you an architectural design of what we're actually looking at. And so what you're seeing here as a user of the system, you might be wanting something like a virtual machine. That VM needs to be deployed through the Azure ARM layer or the Azure Resource Manager. That's the interface that you work with the Azure portal, through templates, which we're talking about, PowerShell, CLI, and REST APIs. It's also at this layer that you're going to implement your policies. We talked about policies as a way to enforce the deployment and the operation of certain types of resources. And by putting this layer in, we can now provide that management for the creation of objects. And so what you have is this ARM layer that then builds the representation of this virtual machine as it exists at the infrastructure of Azure. Now, what we have is also And if you're familiar with the word arm, draw a hand here, there's a bicep, which is a new way to be able to interface with the Azure ARM layer. And that's what they're trying to show you on this slide, is you can use bicep templates. They are a relatively new way to be able to interact with the Azure infrastructure. You can use a traditional Azure ARM template, and a bicep is about 30 to 40% more efficient for the deployment of these resources. And so it is our recommendation that you find some automated way or infrastructure as code to build the infrastructure that you're working with. What this also does is it supports the DevOps model to be able to sit there and not have to build infrastructure and maintain it on a daily basis. You can actually deploy infrastructure only when it's needed. And so when you don't need it, you can deprovision it, saving significantly on costs. Now, there's a series of other tools that you can use, third party. You can see Jenkins and Terraform, two very popular tools to manage infrastructure as code, but all of them are capable to be deployed against Azure. You know, we've got the Azure Resource Manager templates. We've got our bicep capabilities. We have our Azure automation tools inside of Azure to provide automation and the control of the infrastructure that we're working with. We got Azure DevOps as our DevOps tool to manage the CI/CD pipeline that you're working with. We also have another utility inside of Azure called the App Configuration Solution. The App Configuration utility allows you to be able to build a template configuration that represents the mapping of how that should look like. You then can point the service at the resources to make sure that the app is configured in a specific way. This is often used in conjunction with the app deployment through a variety of stages that you might have. Maybe you've got a dev environment, you've got a QA environment, you might have a testing environment, and maybe a production environment. Your application, as it moves through those different environments, maybe it needs different configurations. For example, if I needed a connection string for my application to connect to the database, when it's in development, it probably connects to a completely different database than it would connect to in production. So I can use the app configuration solution to be able to automate that process so that says, as my application moves through these different stages or environments, I want the application to be configured in a very specific way. So designing an app configuration solution is part of the infrastructure to not only make sure that your infrastructure is managed as part of an automated solution, the app controls can also fall into that same management infrastructure. So hopefully you've understand all of the different components and where they come into play into this modern architecture in the decoupling of your applications. I also brought in a little bit of the Azure function features, which we covered in another module, of how you build this, galaxy of bits of pieces that surround your application and ties them all together. So let's go into the demonstration, and we'll show you a number of these capabilities and show you how they tie together and how easy they are to configure. So let's go to that demo. We have quite a few different resources to take a look at, and we're just going to take a quick tour of some of them. Starting off with the two types of message queues that we have, the simplest being the queues, which are part of a storage account. So here I'm in my storage account, and you see I have the other types of storage for blobs, file shares, and now I'm in the queues. Now I already have a queue built. Now within the queue itself, I can start to deposit messages. Now these would typically be done programmatically somehow, but I'm going to do it manually. So I'm going to create my first message. I'm going to add another message to the queue. And we can continue to add messages. As I said, this would typically be done programmatically, and each one of them gets a unique ID, and then this could be read and either left in the queue or deleted. The next type of message-based queue is a service bus, and I've already created the service bus account. In here, I can have queues, and like the other one, I have specific queues, and I've got one I've already created here that will be able to deposit messages into, and you can see that I've got a URL to be able to access the specific queue, and I can come into Service Bus Explorer, similar to what I did with the standard queues. And it's in here that I'm going to be able to take a look at messages. I can take a look at the type of content that I want to put in, and then the body of the message. And I can now see that first message has been deposited into the queue. The next type of queue we want to take a look at is going to be the event-based queues of Event Grid and Event Hub. I've already created an Event Grid namespace. I've already created an Event Grid namespace, and I can get into the eventing where I have my topics. Now remember, the vast majority of Azure features publish topics on all of their capabilities. I can now come in and create a topic that would be a custom topic that could be then published to this namespace. The fourth and final queue are event hubs. Now I've created the event hubs namespace, and within the event hub, we talked about you would then have the event hubs themselves. The hubs would then be created, and in the creation, you would then define one or more partitions. Remember, this has to be done at the time that the hub is created, and you could have up to those 32 that would be the partitions inside of your hub itself. The next thing we want to look at from this module was the API management. Remember, there were several major components. There was the API management service that had a portal that you could then use to publish for developers to come get information. There's the gateway service itself that managed the use of those APIs through users subscribing to products that you might have published. So I've actually created the API management service. We've got our gateway URL, and we've got the developer portal as well. Now, I haven't actually published my portal yet, but I want to show you some of the features that we have. Under the APIs that I've created, I've actually got a demo conference API where I can now come in, and this is going to allow you to use the get operations for get session, get sessions, get session topics. These are all the different requests that we have. We have our front end, we have our inbound filters that we're working with, and then our back end. And so we can have policies that we can use to control the different characteristics of either inbound or outbound traffic. Once I've got my APIs configured, I then could configure them into the various products. And so you can add a product display name, and then you can actually say, do I want to publish, and which APIs do I want to add to this product? You can see that I've put together a Contoso conference product, and it has those conference APIs I just showed you. You then take those products and you create subscriptions where people can subscribe to those products, and I could then either grant access or revoke access based around the keys that are going to be granted to them. Now, taking a look at the portal itself, I haven't actually published my portal yet, but I can get in and take a look at the portal settings, and you can see that I can get in and I've got my front end where I'm working with. I can change all the graphics. I can take a look at the APIs. I could go through the different pages and take a look at the APIs that I've got published. The last demonstration for this unit is on infrastructure as code, and we're going to focus on templates for the deployment of your resources. We said that everything in Azure is represented through a JSON document. I'm going to take a look at a individual resource and then some resource groups, and then we're going to take a look at a library of templates that we have available to us. So I've come into a specific resource. In this case, it's our API management resource. And down at the bottom, you can see that I can export the template that was used to create this object. So if I needed to recreate this or a similar type of object, I could use this template as a starting point for that deployment. Switching over to take a look at an actual resource group where I'm going to have quite a few resources in this resource group, I can now have an export template that will export everything in the resource group. So if I just come back into here, you can take a look at all the objects. There's 28 different objects ranging from virtual machines, virtual machine scale sets, VNets. There's a whole set of resources that would all be redeployed based around that template that I'm working with. Now, I mentioned that we do have a quick start library that has a little over 1,200 templates, and we're constantly adding and modifying these that are a series of templates that can be used to deploy Azure resources. Now, while there may not be a specific template that meets your requirements, I always joke that I don't write code anymore. I plagiarize it. What I'll do is I'll go out and grab one or two portions of different templates and blend them together to create the resources and the creation of those through a template based around creating a unique template by, as I said, cutting and pasting from a variety of different places. But this is a great resource to be able to start your template journey. Let's return to the lesson. So welcome back from the demo. What we've seen in this lesson is that modern application development of microservices and the decoupling of your application itself. And remember, your application in this description is those large bit of business code, whether they be your front-end application, your middle tier, or your back-end data tier. You've got this, I refer to them in my galaxy as they're the planets. They're the large body objects that provide, the substance to your application, although they're broken up into small pieces. We then then decouple those, and we needed ways for them to communicate between each other. And that's where Event Grids and Event Hub for event-based triggering of, hey, when something gets deposited into a storage account, maybe perform some kind of activity, or if someone creates a record or purchases something, I want to trigger an activity to happening. So we take a look at event-based processing. We then took a look at message-based processing and queuing, and that provides that decoupling so that you can have proper scale, and also provides some redundancy in case two features that need to talk to each other, if one of them is not available, it provides you a short-term storage location to have that information reside there, so that when the other application becomes available, you're going to be able to pick up that information. We saw that we had a whole bunch of different types of infrastructure that you can manage, and there's that term that we talked about, infrastructure as code, and we showed you how literally everything that exists in Azure exists in some kind of JSON document, and then where we can use those ARM templates to actually deploy at scale with consistency and efficiency. We introduced a new programming language of Bicep. I love that because, ARM, or the Azure Resource Manager, and if you take a look at ARMs, your Bicep is a way to flex that. So I love the naming convention that they picked up there. So Bicep is the new programming language that you use to manipulate the Azure resources instead of using the JSON templates in the past. So we've seen these different queues, and we've added them to our application development. And we now have this modern environment that supports a platform as a service that you can now leverage very cost effectively, provides massive scale, and provides consistency in your deployments globally. Okay, so that's for this module. Hopefully we'll see you in a coming module and continue learning on Azure architecture. Thanks.